All right, so hello everyone. I'm Łukasz, as Kuba just said, and I would like to show you how to import Python code basically from everywhere. Hence the asterisk here. What are we going to do today? I want to tell you what is the problem that we are trying to solve using the code that I will show you. How the import mechanism works, how to write your own import hooks to be able to do basically the same thing that I will show you. Then I will show you those things, and at the end we'll answer the question, but why? Actually, I will talk about my own motivation first, why I started doing this. Well, there is a game that's called Arma 3 that I'm an avid player. And I'm part of a modding group that makes mods for this game. What we wanted to do was to extend the game's possibilities with Python. So we wrote a plugin that allowed you to write scripts in Python that would be then executed inside the game. And what we needed then, if we wanted to first distribute the mod to players, or to store everything in one single, one nice single package, we wanted this Python code to be stored in a separate place, not somewhere on the user's computer, like lying in a, I don't know, C/Python directory, which would be stupid, because we want also to distribute the thing to those players. So this is why I needed to somehow make my code be imported from the place that I wanted to store it first. So, how to import the code from everywhere? Well, you write a function that's called custom import with the name of the module you wanted to import. Then you fetch the from the internet, for example, and you eval the string, and we're done. So thank you very much. Nice to have you. Nice to have you here. Do you have any questions?
It should be exact, not eval.
Well, that was not a question. Of course. So yes, this is not a good reason, a good solution. Of course, do not use eval nor exec. Why? Well, first, all your code will then have to use functions to import stuff. You usually don't want to do that because you want the code to be oblivious of it running inside your small sandbox or a regular Python installation. You just want the code to have import module, and you want it to work. That's what we are aiming for. So yeah, you cannot do import stuff. You cannot also do from stuff import other stuff. And also, well, in theory, what we could do is change all our imports to the first this version here, and it would work for a really small amount of code, because your code will probably import some other thing that will want to import some other thing, and that's code that you just imported would also have to be modified. So that's why we still want to stay away from using that custom function. Also, a quick primer about importing. If we have such a directory that is called parent, it has two subdirectories, one called 1, the second one called 2. It has a few init.py files and also a file that is called and_a_half. And after that, after creating that folder, we just import everything. We type import parent.1, parent.2, parent.2, and a half. What will happen then? So the first thing, of course, what I've done is I've put some print statements inside the files so that we could see what's happening. So when we import parent.1, what will happen is first the parent module will be imported. After that one is done, it will be put inside, actually it's sys modules. That's a dictionary that contains all the modules that are currently imported. And then it will import the one module. Then when we type import parent2, it will check that the parent module is already imported, and it will skip that step. So it will just import the 2.py module. And after that, when we do import parent 2.5, it will just import the 1.5 part. What we need to know if we want to do custom importing and use import hooks is to know first what a finder and a loader is, because that's what the import machinery uses to import the modules. So first, the finder. The finder is an object that has several methods implemented. Those methods allow the Python code to tell if and where is that Python module located. Actually, it's the finder's job is to tell Python, yes, I can load that module. And once the finder does that, the loader starts doing its job. The loader is also another object that contains that has some other methods implemented that that just load and execute the module. And also, there's one thing that we can do to simplify our job is, we can have the finder and an importer and a loader in one single object, which will just then be called importers. So an importer is just an object that has all those methods implemented. So when we want to import something, what's happening first when we import parent package subpackage.module, the canonical name is derived from that name. When we do just import something, that's the name that we wanted. And if we do from A import B, it's converted to import A.b, and the A.b is the name that will be passed to the finder. So first we get the canonical name, then we check the sysmodules cache, as I said previously. If the module is already there, then we skip the whole process and we mind our business. Otherwise, we try to find the module using all the finders that have been registered prior to running this code. There are three finders, three stock finders inside Python that just import the way you know. And the thing that we will be doing is we'll be creating our own finder, our own loader, and register them afterwards. So once the finder once one finder will say, hey, I know this module, I can load it, then the loader will load that module. So as I said, we go through the sys metapath list that contains all the finders. We call the findSpec method of each finder with the right arguments. One of them will be the canonical name of the module. That finder may return none. If it returns none, it means I don't know this kind of module. Well, let's try with another finder. It can raise an exception, of course, or it can raise a spec object. The spec object contains the loader that will then be used. If all the finders will return none, that means that we cannot import this module, and you get the module not found error exception that you probably know. So yes, otherwise we move to the loading part. The loading part is done by executing the either create method. Yeah, we can use the create method, and if it doesn't exist, there is a default way of creating by Python. And then we exec module. We call the exec module function method to execute the code. This is all quite convoluted, but fortunately, enter import lib abc, abstract base classes. This is a module that's used by Python machinery to simplify everything. So if you started sleeping, well, now is the moment to wake up, because this is where the interesting stuff will start happening. What ABC contains is it contains a few finders and loaders that we can reuse, that we can derive from to create our perfect finder and loader, which will become an importer. The two objects that we want is the metapath finder and the source loader, because they are the most we have the least amount of work to do if we want to make our own importer. For the metapath finder, well, it's a finder that is stored in sysmetapath, and it contains the abstract method find spec. This is how the boilerplate will look like. So what we want to do is, well, we first derive from metapath finder here, and we create our find spec method. What we have to do first is we have to check if we can import that module. So it's here, and then return a module spec with our loader and the information whether that is a package or not. So as you can see, the only thing that you have to actually replace here is the can import function, the myLoader, obviously, because we have to give our loader then, and a function or method, whatever, that will then discern a module from a package. Packages contains modules, of course. So this is the finder part. And for the loader, then, well, that's an abstract base class that implements the file loading. You can either import from load from source or from bytecode. So that's as you wish. You can also add additional caching if you want to afterwards. And it contains two methods, quite simple actually. The get data and get file name. And also, if you want, there's also one important thing. It is very easy. You have to use another loader if you want to import files that have been compiled. That, for example, with Cython. It is also very, very easy to do. You just have to use a tiny, well, a loader that's a little different from the source loader. How does it look? Well, you have the get file name method. So you have to implement it yourself somehow. Like you have to check in your own directory or in the memory whether you have a dunder init.py file. If you have, then this is a package. Otherwise, if you have a module name.py file in your virtual file system that you want to expose, then it's a module. So you get the full name of the module, and then you return the file name that will then contain the data that you want to execute. And so after that, the getData function, or rather a method, will get executed. It's just something that actually fetches the data and returns the string that will contain Python code. So those are the two functions or methods that you have to implement yourself. If you want to do that in one step, you just create an importer that will derive both from source loader and meta pathfinder, and will contain the exact same 3 methods. After that, we want to register the finder, the importer, by just adding it to the sysmetapath list. And just doing that will ensure, well, in this case, what we're doing is we are inserting it at the first position, which will ensure that our loader, our finder or our importer will be executed as the first one, which we may or may not want to do. If we put it in the first place, we can overwrite everything. We can take over importing all the modules that are imported by Python from that moment when we insert the finder to the list. So now it's demo time. So what we have here is we have our data. So this is our virtual file system that contains one simple directory and a file dunder init dunder.py that will contain a print statement executing intercept modules.init.py. What we do is we need a getFileName function that will just replace the dots with slashes, because that's, as you know, the packages are delimited by dots. And here, if we want to simulate a virtual file system, we use slashes. And then we just append .init.py to know if this is a package. So then we just return this name. Otherwise, we return module name.py. If that doesn't work, we return key error. We also have a function to check if something is a package. We just check if there is a module name / init.py entry in our data directory. If it does, this is a package. So those were the 2 functions that were outside the importer. Inside the importer, we get the file name, we get the data here, and we import all those stuff. After that, we can just insert the importer, and when we do import custom module, what will happen is just this print statement will be executed. So this will just look like this. The importer tried to load the custom module. It requested the file name. The file name was found to be custom module / init.py. And then it was returned to Python, and Python executed the code and hence printed this message. So right now, what we can do is we can quickly, once we have our boilerplate code, what we can do is we can create our own importer almost from scratch by making a few changes to that boilerplate code. So the boilerplate code, I have it here. What we have, that we will need to implement is the isPackage function. Check a few things here and return the data. We have a few helpers. Oh, what are we going to do actually? We are going to import modules directly from GitHub. So, you know, sometimes you just don't want to install the requirements. You're too lazy, so you want to import directly from GitHub. So what we will be doing is we will, let me see, it's here. What we want to do is to type import GitHub overflow, that's my nickname, import hooks, hello. So what this will do is it will go to GitHub. It will go to GitHub, go to import hooks, and fetch this file and execute it. So we have our two helper functions. One function that just fetches an HTTP page from GitHub, and the other one that converts our module name to the right URL, row GitHub user content.com user project path. So now let's start creating our own importer. What we want to do first is to check if the package, if a full name of a module is a package or is a file. Is a module, I mean. So what we will do is we will check if there is the init.py name. So first, what we will do is we will create a base URL using our function, our helper function here, and we will just derive that from the full name and add .py at the end to check if that function, if module.py does exist. So this is the URL, and now if that URL, we will just get it. So we'll get that URL, and if that URL is none because we couldn't find that file, we will just assume it's a package, so it will return true. So we type return get that file is none. This is our package check. So then we can start working on the Finder. What we'll do do here is we will check if the module name that we want to import, which will be GitHub overflow import hooks, if it starts with GitHub dot something, because this is something that we can handle with that Finder and our loader. So basically, we just do if not name, starts with GitHub, return none, which means, as I've shown on the slides previously, it means I cannot load that module, let the other modules handle this, let the other importers handle this module. And basically, we're done with the Finder here. So we go to the loader, and we have the URL here already created. And so if it's a package, we want to return the name of the file that will contain the module to be imported. So what we'll do here, well, we just check if it's a package. So if is package full name, then we can return here the URL plus init.py. Otherwise, what we do is we just return URL plus plus .py. So this is the get file name part, and we get the data. This is a small workaround that I had to add because when we will import the things, we'll first import GitHub and then GitHub overflow and then GitHub hooks. So those modules, they don't have any corresponding file, neither .py nor dunder init.py. So this is a special case that I've just added here. And then we just fetch the file. So what we do is we return the GitHub file name. Because the file name here that we will return will be the URL, either this URL or this URL. And after we're done with that, we just install the Finder and let the code run. So now let's hope I haven't made any errors here. Python test hello. And we are executing the code directly from GitHub right now. So this is one thing that we can do. If we want to go further, for example, sometimes you know something like Stack Overflow-driven programming. It's simple. You have a problem, you ask, at least one person knows. We just open Stack Overflow, we type our problem, we get the first answer, we paste it to the code, inside the code, and we run everything and pray that it works. Well, yes, that's a good way to work, but you can do it much simpler. You can create an import hook that does the same for you, so that you just import from Stack Overflow your problem, and you execute it. So this already has been implemented by someone, but well, there we had to make a few changes, me and Janusz, to make it work. Let me see. Well, actually, this is on GitHub. So what we can do is we could use we could do an importception right now. So we will use the import hook that I've just written to import the code from GitHub to import code from Stack Overflow. What? You don't do that at work? Good answer. So the code here is a little more convoluted, but whoopsie. We will import things from Stack Overflow. From GitHub. Sorry, we will import the Stack Overflow thing, and then from Stack Overflow we will import quicksort. So what this does is it uses the Stack Overflow API to search for quicksort and Python. Then it finds the most upvoted question, opens it, finds the most upvoted answer with a block of code, and execute that block of code. So we have the arguments here that we want to sort. And what we do now is the Python. Sorry? No, it's OK. Oopsie, I have an H. Yes, because I want to do it here. So this is what you've seen already. Actually, this normally works faster, but I'm on a cellular connection. This is, you can ignore that. Yes? Yes, true. Yes, we could check what's the problem on Stack Overflow right now, but from what I remember, it will work anyway. We have the args. We have the quicksort. Yeah, quicksort. We have the quicksort module. It's been imported. What we can do, we just check what are the methods here. We have a method that's called quicksort. So quicksort, and we will get some help first. So sorry. Well, yeah, I think you could if you'd well, it could be possible, I think. But anyway, we have the quicksort. Well, this one takes self because the answer had a self argument. So what we'll do, we'll just pass none to that because it doesn't use it's not a part of the class anyway, from what I remember. So we do quicksort, none, args, and ta-da! It's done. So next time you will know how to search Stack Overflow with class. Exit. Now let's go back to the presentation. What are the possible uses of this thing? Well, I've heard about people storing Python code in a database. Honestly, I don't really know why, but they were doing this for their company, so they must probably have had a good reason to do so. As I said, I don't really know why, but I know that there are definitely people who do that. Well, maybe. Who knows?
They should store it in the blockchain.
Yes, storing code in a blockchain could be a good way also. But what we can do is we can generate code on the fly. We can generate code depending on who's asking, because well, if you have, you can create, well, you can set up your own web server that will just print the code to be executed, and depending on the user that will connect to you, you can give him different Python code. You can generate the code based on time if you want, like to have you know those kinds of things like RSA tokens. You can create your own py2exe or PyInstaller. If you don't know what it is, it's something that packages your Python code and creates an executable out of it, so that you can have a .exe file that you can just give away to a friend, and they will be able to execute it without owning Python or installing anything. So those definitely need your own importers, because you don't want you want to have Python code that will not depend on what's on the user's computer, because they may not have that library that you want, or they might have it in another version, or maybe it's modified, and your code will then not work. You can use that to store code in a proprietary format. If you embed Python in applications, just as we did with the mod for Arma 3. Or you could implement some kind of DRM. Now, I don't really want to go into the discussion whether DRM is good or bad. I'm just telling you that it is possible to make some kind of DRM. And it's not really hard because, well, I've done it here. So that's another cool thing that you can do. So let's check what it is. Actually, that's an Arduino. You can see there's a red light here. If you switch the flip, if you flip the switch, there's the green light. So what will happen is that what we want to do, go back to the demo directory. We have the Arduino demo here, and the switch is actually an easy way right now to show you that I can say that this person is authorized to run some code, or they are not. So right now they are not authorized, and I'm running the code. It's making some dramatic pose. And no, well, it threw an import error. That's because the red light was here. So what we do now, we can flip the switch.
So wait, the code is imported from there?
Yes, well, everything that's besides my importer has been, well, let me show you it. Let me show you the code. That will be simpler. Arduino Inno. That's the code. It's just printed out through a serial interface. So what's happening is that now we are authorized to run the code somehow. And we run the demo again. Ta-da! So yes, you can implement your own DRM if you want to sell your own game and protect it somehow. Of course, the next step is using that for CTFs, so for breaking the DRM that I've just implemented. That's also possible. That could be a good idea. Yes. I'm waiting for your next CTF task. And basically, that's all. If you want to check this further, I suggest you to read the documentation about import lib. And what's also good is the PyInstaller source code, which shows you how, PyInstaller has to handle all Python versions starting from, I think, Python 2.6 or maybe even earlier. So if you check the source code, you can see all the workarounds that have been needed to be implemented, all the changes between the Python versions. This is kind of an interesting file to look at. And also you can see an implementation of a loader that will allow you to load compiled code, like the one with Cython. And also, yes, you can check the Stack Overflow import and the GitHub import from here. So yeah, that's all. Thank you. And do you have any questions? Oh, no.
Have you looked what the Cython importer does?
Sorry?
What the Cython importer does? Because you said that this can be used. This is actually used to import things whenever you have the Cython code. So what exactly does it do?
To be honest, I don't really remember. But one thing is that Python code is just bytecode, and Cython code is compiled code. So you have a DLL inside, so it just has to load the thing. This is kind of awkward because I've even made use of that importer in the past, but that was around 2 years ago, so I don't really remember. The thing is, you just have to use that other importer, and it just works. That's from a regular developer side. That's all that's needed to know.
Yeah. Okay. Thanks.
Sorry, thank you. So is there anything around checking for the security of the code? Because especially for import Stack Overflow, even if it's the most voted answer, people might have concerns with running code they don't know on their machine. Well,
first thing, I would suggest not doing that in production. I know. I don't expect you to do that. It's actually the same thing as with exec, eval, and other unsafe functions. You would have to first, you are responsible for ensuring that the code that you want to run is safe. You just treat it as if you were executing the code with eval.
You can sandbox the code.
Yes, that's also a solution, but yeah, but the simplest way to put it is just treat everything as if you were executing that, as if you were using eval.
There is also something called exception hook inside the Python, so you can hook your function to search for an answer for an exception automatically on the Stack Overflow. Yeah.
Actually, yeah, that's a good idea. That's a good idea.
That's her idea.
Thank you, Celine. I'm waiting for your pull request.
Okay. Do we have any other questions? Okay. So I think an applause for Łukasz. Thank you for your presentation.
Thank you very much.